Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using reduction of order method. So let's get going. Problem: use reduction of order method to solve y double dash plus 1 minus cot x into y dash minus y cot x equals to sine square x. So we are given a differential equation of order 2 and also it has variable coefficients, right? So now we are going to use reduction of order method. Given differential equation, y double dash plus 1 minus cot x into y dash minus y cot x equal to sine square x, or we can write it as y double dash plus 1 minus cot x into y dash minus cot x into y equal to sine square x. Consider it as equation number 1. Now compare the given differential equation or equation 1 with the standard form of second order linear differential equation y double dash plus p into y dash plus q into y equal to r. Now by comparing these two, we'll get p, q and r. We get p 1 minus cot x, q minus cot x, and r is sine square x. Now we need to find the part of complementary function of 1 or the solution of homogeneous equation of 1. Okay, so let's find the part of the complementary function of 1 using inspection method. Okay, see the part of CF of 1 or the solution of homogeneous equation of 1, both are same. Okay, don't get confused. So let's find the part of CF of 1 using inspection method. In order to find the part of complementary function of 1, I just only need p and q, where p equal to 1 minus cot x and q equals to minus cot x. If you observe, we are having p 1 minus cot x and q is minus cot x. So let's try for 1 minus p plus q. 1 minus of p, 1 minus cot x plus q is minus cot x, which is equals to 1 minus 1, minus into minus plus cot x minus, plus into minus cot x. Here minus cot x plus cot x minus 1 plus 1 gets cancelled, this is equals to 0, right? Therefore 1 plus p plus q equals to 0. Since we know that if 1 plus p plus q equals to 0, then it is 1 minus, right? If 1 minus p plus q equals to 0, then y equal to e power minus x is the part of CF of 1. Okay? Therefore, y equal to e power minus x is the part of CF of 1, where u equal to e power minus x. If u equal to e power minus x, then derivative of u with respect to x is minus e power minus x, right? Just consider u equals to e power minus x and differentiate on both sides with respect to x. You'll get du by dx equal to derivative of e power minus x with respect to x is minus e power minus x. Okay, you'll get the same thing. Now let y equal to uv be the general solution of 1. Then see, we have u, which is e power minus x, but we need to find v. Then v is given by d square v by dx square plus p plus 2 by u into du by dx into dv by dx equal to r by u. Consider it as equation number 2. Now substitute u, v, r, u and p in order to find small v. So from this we'll get capital V, and from capital V we'll find small v, and later we'll put u and v in y equals to uv to find the general solution of the given differential equation. This becomes d square v by dx square plus p. P is 1 minus cot x plus 2 by u into derivative of u with respect to x into dv by dx equals to r by u. Okay. Here e power minus x gets cancelled and we'll get d square v by dx square plus 1 minus cot x plus 2 into minus 1 into dv by dx equal to sine square x by e power minus x. I'll write e power minus x as 1 by e power x for my convenience. Okay, this becomes d square v by dx square plus 1 minus cot x minus 2 into minus 1, or minus plus into minus minus 2 into 1 2 into dv by dx equal to e power x sine square x. This becomes 1 minus 2. 1 minus 2 is minus 1 minus cot x into dv by dx equal to e power x sine square x. Now let dv by dx equals to capital V. Then d square v by dx square will be d capital V by dx. Now the above equation becomes d capital V by dx plus of minus 1 minus cot x into capital V equal to e power x sine square x, which is a linear equation in capital V and x. Which is linear in V and x. Now just compare this differential equation or this equation with the linear differential equation standard form. In v and x, say dv by dx plus p1 v equal to q1. So by comparing these two, we'll get p1 and q1, where p1 equals to minus 1 minus cot x and q1 equal to e power x sine square x. Now we need to find integral p1 dx, and integrating factor is given by e power integral p1 dx, and later we'll use the general solution formula of the standard form of linear differential equation. V into integrating factor equals to integral q1 into integrating factor into differential dx plus some constant, say c1. Okay, now let's find integral p1 dx. This is equals to integral of minus 1 minus cot x dx. This is equals to minus integral dx minus integral cot x dx, since integral cot x dx is equals to log sine x or log mod sine x. So you'll get minus x minus log sine x. See, if you are not that good at remembering the formulas, you can just find integral cot x dx using the formula integral f dash of x by f of x into dx, which is equals to log mod f of x. Okay, we can write cot x as cos x by sin x if f of x is sin x, then f dash of x will be cos x, right? So this is of integral f dash of x by f of x dx form, right? So we'll get, if you apply this formula, we'll get log mod sin x or log sin x simply. Okay. Let's now find integrating factor, which is given by e power integral p1 dx. This equals to e power integral p1 dx is minus x minus log sin x. And we can write this as e power minus x into e power minus log sin x. We know that m log n can be written as log n power m, right? So we can write minus log sin x as log sin x whole inverse. Okay, this is equals to e power minus x into, also we know that e power log some function of x equals to function of x. So we'll get e power log function of x is function of x, right? Which is equals to e power minus x into, we can write sin x whole inverse as 1 by sin x, or this is equals to e power minus x by sin x, or you can write this as e power minus x as 1 by e power x into 1 by sin x, which is equals to 1 by e power x sin x, better, right? So we got integrating factor 1 by e power x sin x. Okay. Fine. Let's now use this formula to find capital V. V into integrating factor 1 by e power x sin x equal to integral q1. Q1 is e power x sin square x into integrating factor 1 by e power x sin x into dx plus c1, right? Which is equals to, here e power x and 1 sin x gets cancelled, or we can write this as, let's write sin square x as sin x into sin x by sin x into dx. You can write directly, okay? This is equals to, you can write directly sin x also, okay? To cancel 1 sin x here itself, we'll write the direct step. Otherwise, we'll just write this sin square x as sin x into sin x for your convenience in order to reduce the mistakes. Integral sin x dx is minus cos x plus integral constant c1. Okay. Now we have v into 1 by e power x sin x equals to minus cos x plus c1. Now take 1 by e power x sin x to RHS, we'll get minus cos x, v equal to minus cos x plus c1 into e power x sin x. Then v equal to minus e power x sin x into cos x plus c1 e power x sin x. So we got v. Okay. Let's replace v with, since v equal to dv by dx, so we'll replace capital V with dv by dx. Okay, equals to minus e power x into sin x cos x plus c1 e power x sin x. We know that sin 2 theta equals to 2 sin theta cos theta, right? Then if you bring this 2 to LHS, we'll get sine 2 theta by 2 equal to sine theta into cos theta, right? So now we can replace sine x cos x with sine 2x by 2. Okay, we'll get or multiply and divide 2 to this. Okay, then we'll get minus 1 by 2 e power x into 2 sine x cos x plus c1 e power x sine x, which is equals to minus 1 by 2 e power x into, just replace 2 sine x cos x with sine 2x. You can use this identity. Either you can use first or second identity. It depends upon you. Your choice. Okay. Now let's separate the variables. In order to separate the variables, I'll take the differential dx to RHS. Then I'll get dv equal to minus 1 by 2 e power x sine 2x plus c1 e power x sine x into dx, right? Then dv equal to minus 1 by 2 e power x sine 2x dx plus c1 e power x sine x dx. The variables are separable. Here the variables are separable. So now we can perform integration. Integral dv equals to minus 1 by 2 integral e power x sine 2x dx plus c1 integral e power x sine x dx. Okay, let's find each integral separately for our convenience. Okay, plus some integral constant, say c2. So here we are going to apply a formula, integral e power ax sine bx dx equals to e power ax by a square plus b square into a sine bx minus b cos bx. Okay, I'm going to find the first one of RHS, integral e power x sine 2x dx. Just compare the integrand with the formula. Then for a equal to 1, b equal to 2, we'll get e power 1 into x by 1 square plus 2 square into a sine bx minus b b cos bx, which is equals to e power x by 1 plus 4, 2 square is 4 into sine 2x minus 2 cos 2x, right? Which is equals to e power x by 5 into sine 2x minus 2 cos 2x. Okay, so for this we got e power x by 5 into sine 2x minus 2 cos 2x. Let's now find for the second integral. Integral e power x sine x dx. Now compare the integrand with the formula. Then for a equal to 1 and b equal to 1, we'll get e power 1 into x by 1 square plus 1 square into 1 into sine 1 into x minus 1 into cos 1 into x, which is equals to e power x by 1 plus 1 into sine x minus cos x, which is equals to e power x by 2 into sine x minus cos x. So the result obtained for integral e power x sin x dx is e power x by 2 into sin x minus cos x. Okay, now coming to integral dv. This becomes v equal to minus 1 by 2 into integral e power x sin 2x dx is e power x by 5 into sin 2x minus 2 cos 2x plus c1 into integral e power x sin x dx is e power x by 2 sin x minus cos x plus integral constant c2 is equals to minus e power x by 2 5s are 10, sorry, or we can just write it as minus 1 by 2 5s are 10 into e power x into sin 2x minus 2 cos 2x plus c1 by 2 into e power x into sin x minus cos x plus c2, which is our required v. We got v and already we have u. So let's write the general solution. The general solution is given by y equal to u into v, where u is e power minus x into v minus 1 by 10 into e power x of sin 2x minus 2 cos 2x plus c1 by 2 into e power x times sin x minus cos x plus c2. Then y equal to minus 1 by 10 into e power x into e power minus x into or of sin 2x minus 2 cos 2x plus c1 by 2 into e power x into e power minus x of sin x minus cos x plus c2, right? This equals to, see, we know that e power minus x can be written as 1 by e power x, then e power x gets cancelled and equals to 1, or we can write or add the powers. We'll get e power x minus x, which is e power 0, since e power 0 is 1, so we'll get 1, right? Let's now replace e power x into e power minus x by 1. Then we'll get minus 1 by 10 into 1 into sin 2x minus 2 cos 2x plus c1 by 2 into 1 into sin x minus cos x plus c2 is equals to minus 1 by 10 into sin 2x minus 2 cos. Here, after multiplying c2 with e power minus x, we'll get e power minus x here. Okay, c2 e power minus x, fine, plus c1 by 2 into sin x minus cos x plus c2 e power minus x, or we can write it as, firstly write the terms involving arbitrary constants, c1 by 2 into sin x minus cos x plus c2 e power minus x. Now write this term, minus 1 by 10 into sin 2x minus 2 cos 2x. Okay, we can replace the constant c1 by 2 with some other constant, say c1 dash or c3. Okay, I'll replace with c3. Or then y equal to c3 of sin x minus cos x plus c to e power minus x minus 1 by 10 times, or 1 by 10th times, sin 2x minus 2 cos 2x. Okay, if we have replaced c1 by c2 with some other name, say c1 dash, then you'll get, or y equal to c1 dash of sin x minus cos x plus c2 e power minus x minus 1 by 10 of sin 2x minus 2 cos 2x. This completes the problem. So we have seen a problem from reduction of order method in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.